शांति चारों ओर, होगी शांति चारों ओर, होगी शांति चारों ओर। एक दिन वो मन में है विश्वास, पूरा है विश्वास, होगी शांति चारों ओर एक दिन।
Dear students, you are appearing a very important exam in your life amidst this pandemic situation. SSC board exams are nearing. At this penultimate stage, we have decided to lessen the anxiety and stress you are undergoing. A series of content-based videos are offered by a team of experienced teachers through Aseem Dnyan Vahini, a great initiative by Shri B.B. Jadhav. The study material is constituting of chapter-wise lessons of Science-1 and 2. It includes important concepts, paper pattern, revision, and board questions. To start with, I'll just share my screen. SSC at one glance, a complete guidance series. Concept, direction, and coordination by Mr. B.B. Jadhav. A video that every student of SSC must watch for complete revision and understanding. Myself, Mrs. Shama S. Varanzu from BPM's Vidya Mandir, Daisar East. Technical guidance, Mrs. Megha Mahadev Rani. Today's chapter is from Science-1, chapter number 1, Gravitation. Before we begin with the concepts, let us see the paper pattern of Science-1 and 2. It is similar. Question number 1A is MCQ-based question, which are questions based from the textbook only. There are in all 5 questions which will come. Each question is for 1 mark. You are not expected to write the statement, but just mention the answer and the option number. Question number B is also objective questions of 1 mark each. So in all 5 marks, there will be no fill in the blanks in the question. It may include odd man out, say true, false, right or wrong. Such questions can be included. Question number 2A is give reasons, any 2 out of 3. Each question is for 2 marks. Question number 2B are questions write in short. Any 3 out of 5. So here it is 2 marks each. So it is 6 marks. Here, questions like solve numericals, write laws, principles, properties, uses, give difference between can be asked. Question number 3 is answer the following, any 5 out of 8. Here, it is each question is comprising of 3 marks. You are expected to write answers in 2 to 3 sentences. Your questions can be included is complete the table or the chart, explain with the help of diagrams, complete the paragraph, write laws, theories. Question number 4 is a long answer type question where it's only any 1 out of 2. It comprises of 5 marks. Here, questions can be asked like conceptual diagram, complete the table, answer in detail, or maybe a paragraph given and 5 short questions can be asked of 1 mark each. Now, to solve this paper within the time limit of 2 hours, that is 120 minutes, we need to have a time management. So, roughly a time management is given to you all. If the first 10 minutes is utilized for reading the paper, next 20 minutes can be utilized for the question number 1. Question number 2, you can utilize 30 minutes. You can attempt question number 3 for 40 minutes. And the last question number 4, you can attempt in the 10 minutes. At the end, you have still 10 minutes left. So you can comfortably recheck your paper to complete the paper in 2 hours. So let's start with the first topic, that is gravitation. Now, gravitation is a very common word which you have been hearing past so many years. Gravitation is quite synonymous to the term Sir Isaac Newton, because he discovered when he saw an apple falling from a tree on the ground. He wondered, why did the apple fall in the downward direction? Why did it not fly off in the horizontal? Or why did it not go vertically upward? After a great thought, he concluded that there is a force which is attracting the apple downwards, and that force he named it as gravitation. What is the importance of gravitation? Gravity keeps the moon, earth, planets orbiting. It also prevents the atmosphere from losing from the planets and binds galaxies together for billions of years. So you see how important is gravitation. So let's see the next concept in this lesson. Now, astronomers were always attracted towards knowing what are the facts of planets and suns and other heavenly bodies. So, the motion of a planet around the sun was observed by Johannes Kepler when Galileo's telescope was introduced. Thereafter, he stated 3 laws, which are: seeing the planets which revolve around the sun, he noticed that the rotation orbit is an ellipse, and that became the first law. The orbit of planet is an ellipse with the sun at one of the foci. The second law is, when a planet moves around the sun, it covers equal distance in equal intervals of time. What does it mean? That when a planet moves from point A to point B, likewise, after a certain interval of time, if you see the planet moving from point C to point D, or it moves from point E to point F, the shaded portion is showing the area. The area of the section ASB is equal to section CSD, and it is equal to the shaded portion ESF. This was noticed after equal intervals of time that an equal areas have been covered, and that's the second law. The line joining the planet and the sun sweeps equal areas in equal intervals of time. Let's see the third law. The third law talks about the period of revolution. The square, it is measured as the square of its period of revolution around the sun is directly proportional to the cube of the mean distance of the planet from the sun. Now, to understand this law, it's more easier if you look at this equation where it is t square is directly proportional to r cube. T is the period of revolution of the planet around the sun, and r is the distance of the planet from the sun. So it is t square is directly proportional to r cube. So this was the third law. From the exam point of view, these 3 laws are very important. Newton's universal law of gravitation. Now, it states that when there are 2 heavenly objects, M1 and M2, there is a force which is existing between both these objects. With a distance of d away from each other, the force what exists between them is directly proportional to the product of their masses, and it's inversely proportional to the distance between the masses. In short to say, if you show the gravitational constant, which is G, it says F is equal to G, that is M1 into M2 upon D square. So the definition goes for Newton's universal law of gravitation. It is a definite force with which every object in the universe attracts every other object, is directly proportional to the product of the masses of the 2 objects, and it is inversely proportional to the square of the distance between them. The value of G was introduced by Henry Cavendish, and its value is 6.673 into 10 raised to minus 11 Newton meter square per kg square. Acceleration due to gravity is the next concept. Here, the value of G is noticed as 9.77 meters per second square. and its formula is G is equal to Gm upon R square, where G is the gravitational constant, M is the mass of the Earth, and R is the radius of the Earth. What is the value of G on the Earth? Is it going to be the same? No, it isn't. So let's see how does it vary. On the surface of the Earth, the value of the G is different. Now, why is it so? Because the shape of the Earth is not even. It is slightly bulging at the equator and flattened at the poles. So the value of G is highest at the poles and it is lowest at the equator. How about the value of G at height close to the Earth? For an aeroplane which is flying very close to the Earth at 10 kilometers to the surface of the Earth, the value of G remains the same. But to objects which are at a great height, like Mount Everest, man-made balloon, weather satellite, communication satellite, the value of G decreases with increase in the height of an object. What happens to the value of G deep inside the Earth? The value of G decreases as we go deep inside the Earth. So you can see the value of G is varying at these three instances. Let's move to the next concept, that is free fall. Now, when you drop an object from a height, it comes under the force of gravity and it comes in the downward direction. But there are other forces also which are acting on that object. For example, it can be the buoyant force and it can be the frictional force. What if this object is falling freely? Means if it is falling where only under the influence of gravity alone, then such a falling object is called to be a free fall. So whenever an object moves under the influence of force of gravity alone, it is said to be falling free. Can we achieve this object, such kind of a condition? Yes, it can be only possible when it is done in a vacuum. Now, where are such examples? Where do you find such free fall around us? It is the moon and the artificial satellites which are revolving, orbiting. They are moving under the influence of only the gravitational field of the Earth, as there is no atmosphere in the space. Thus, they are in free fall. Let's move to the second last concept, that is Newton's equation of motion. Now, Newton's equation of motions are very important because they help us to derive the velocity of an object falling freely and the time taken by this object to come down. So, Newton's equations of motions, which we had studied in the lower classes, can be used like velocity is equal to gt, where g is acceleration due to gravity into time. So you get a relation between velocity and time in the first equation. Equation 2 is s is equal to half gt square, which means s is displacement, which is equal to half into acceleration due to gravity into t square. The last equation is v square is equal to 2gs. These formulas are very important when we have to solve word problems. The last concept in the lesson of gravitation, is escape velocity. Now, we've always wondered, we have rockets and various satellites being launched into the space. They move to an indefinite distance. They move to the outer space. Now, how is it possible? Now, then naturally they need to be not under the influence of gravity. They have to move very fast. In fact, they have to have a very high velocity. So when an object going vertically upwards from the surface of the Earth, having an initial velocity which is equal to the escape velocity, so that it escapes the gravitational force of the Earth, then you say it is an escape velocity. So what is the escape velocity of Earth? Here it is 11.2 kilometers per second. So thus we have finished the concepts which are very important in this chapter with this topic. Let us now see some SSC board questions which have occurred in the past. The first question for you, Write the proper answer in the box. This occurred in the March 2019 for 1 mark. Here we have two figures where the first figure is mass 1 and mass 2 and they are separated by a distance of d. And the second figure, the masses are separated by a distance of 3d. So if force which is given as G into m1 into m2 upon d square, then what would be the force acting on the second figure? Think what could be the answer? Yes, it will be once again the same, but here it will be G m1 into m2 upon, it is 3d the whole square. So the answer you get is 9d square. The next question, solve the word problem. Now this was asked in March 2019 for 2 marks. A metal ball of mass 5 kg falls from a height of 490 meters. How much time will it take to reach the ground? Given the value of G as 9.8 meters per second. Now when you solve a word problem, you have to have steps. The first step is the given part. So you have to write down all what is given. The mass of the metal ball, which is 5 kg, distance traveled by the metal ball, 490 meters. Initial velocity of the metal ball, u equal to 0. And acceleration due to gravity is 9.8 meters. Now here we are going to take where S and the value of u and g is given. We will be using Newton's second law for finding out the value of time. So S is equal to ut plus half at square. Substitute into the formula and you can see you get the value of t as 10 seconds. So metal ball takes 10 seconds to reach the ground. Each steps carry half a mark. So the question is for 2 marks. We move to the next question. What would be the value of G if its mass was twice and its radius was half of what is now? This occurred in March 2019 for 3 marks. Here again, you have to take Earth's gravitational acceleration formula. G is equal to gm upon r square, where m1 is twice m and r is half that of r. So when you substitute the value towards the end, you get the value as g1 is equal to 8g. If you can notice, there are marks written on the right hand side. So it is half mark for each steps and the total makes it to 3 marks. So if you solve this question stepwise, you will get the desired marks. We'll revise now the concepts what we studied in the form of fill in the blanks. As I ask you, you should be ready with the answers and you can jot down your answers in your paper or keep it in your mind. Let's see these questions. The first fill in the blank for you on the screen. The acceleration due to gravity does not depend on the dash of the body. Can you tell us what can be the answer? Think. Yes. The answer is correct what you thought. It is mass. The acceleration due to gravity does not depend on the mass of the body. Next question. According to Kepler's first law, the orbit of the planet is an dash with the sun at one of the foci. Yes, what could be the answer? Has it clicked your mind? Yes, correct. The answer is what you thought, ellipse. Perfect. Question number 3 on your screen. According to Kepler's third law, t square is directly proportional to r raised to n. Can you say what is the value of n? Think. Yes? Correct. You have guessed it correct. It is, the value is 3. The next question for you on the screen. Due to dash, the earth attracts all objects towards it. It's due to gravitational force. Correct. You guessed the correct answer. The next question for you on the screen. The value of acceleration due to gravity is dash as we move from equator to a pole. What could be the answer? Think. Yes. Correct. Whatever you thought was right, it increases as we move from equator to a pole. Sixth question for you. At the center of the Earth, the value of acceleration due to gravity becomes dash. What is the answer? Here comes, it is 0. So acceleration due to gravity, the value of g is 0 at the center of the Earth. Name the force that keeps a satellite in the orbit around the Earth. What could be the force that keeps the satellite orbiting around the Earth? Yes, it is the gravitational force due to the Earth. Say whether the statement is true or false. Newton's first equation of motion gives the relation between displacement and time. Say whether it's true or false. Think. Yes, you guessed it correct. It's a false statement because it's a relation between velocity and time. Next question for you. Say right or wrong. The value of g decreases as we go deep inside the Earth. Is it right or wrong? Right, and your answer is right. Here are a few questions for your assignment. You can solve these questions because as in the boards, we have these questions being asked several times. Define the following: Newton's universal law of gravitation, free fall, escape velocity, gravitation, acceleration due to gravity. State Kepler's laws of planetary motion can be asked for 3 marks. It was asked in the March 2020. State the variation in the value of g. This can be asked for 3 marks question. Yes, we have just completed the entire video, the entire lesson. I'm sure you have understood. If you are able to attempt, these questions, I'm sure you'll be doing very well in this topic. We have covered all the questions in the revision section related to the concepts of gravitation. If you were able to attempt all questions, as I said, then I'm sure you will be faring well in the exam. If you have found this video useful, then kindly like, share, and subscribe Aseem Dnyan Vahini. A similar set of quality videos based on other chapters in Science 1 and 2 will be soon uploaded in future. Also, if you have any questions and doubts related to the chapter done today, you can write into the comment section. We will surely solve them. Till then, best wishes for your upcoming SSC exam. Thank you.